Glad to meet everyone. My name is Chen. I work for Pinterest. Today, our talk will be focused on how we build a manageable Flink platform from scratch in Pinterest. So a little bit of background. What Pinterest's mission is to bring everyone the inspiration to create a life they love. So the basic usage pattern is people go to the Pinterest website or their mobile app and browse through all those pins, trying to discover the inspirational content and group them on their private pin board. So the scale of Pinterest is a web scale. It's enormous. Every month, there are 340 million people coming into the platform and growing very rapidly. And we have in total, as we speak right now, more than 200 billion pins of visual contents. We have 4 billion plus pin boards created by the pinners. And every day we do around 20 billion plus recommendation to the pinner to help them, give them inspirational content they really love. So agenda for today would be 5 sections. First, we'll start with a bit of history of streaming at Pinterest, and then goes back to why we choose Flink as our go-to platform, go-to technology. Second, we'll cover some production use cases we are running right now, which are covering major key initiatives in Pinterest. Third, we'll talk about all the processes, tools, services we build in-house to support those use cases run reliably and efficiently. And then we will use a real use case to kind of chain those together and give the audience a holistic picture how it works end to end. At the end of the section, we'll have 5 to 10 minutes to answer any question from the channel virtually so that all the questions can get answered. So now let's get started with a bit of history. So streaming processing at Pinterest really started from 2014. That's when we have some use cases trying to process some logs or DB changes asynchronously. Back then, the whole company wasn't able to find a great technology. So what happens is there are some engineers trying to write some asynchronous scheduler based on MySQL database. That works pretty well for a year until we hit some performance bottlenecks because, of course, as a company, the rapid growth means rapid ramp up of scale. So in 2015, we introduced KafkaStream as our go-to technology. There are a couple of high impactful use cases running in KafkaStream. And then it runs for okay for a year until we saw some issues. In 2016, we introduced Spark streaming on Mesos to kind of tackle those issues in Kafka streaming. And then for a year or two, we saw another couple of certain issues with the scalability and feature lags. So in 2018, the whole company, or especially in data work, starting looking holistically. We have 3 legacy technologies. None of them seems to addressing the particular needs. Nothing, not even cover the future projection. So we start to consolidate and really evaluate what's the right choice as streaming. So in 2019, after a couple of discussion and evaluation, we come to a conclusion Flink is a go-to solution for streaming and streaming-related use cases that can cover what we have right now and what we will have in near future. So we start with the POC use cases, a relatively simple use case. And at that year, we were able to launch this project to production. We also managed to upgrade from 1.72 to 1.91. Along the way, we figure out how to bring a dev job to production and build some kind of manual guidance we call it production certification process. The same year, we built a unified source to make our on-call or go-to-production process much faster. As still in 2019, we built the job services, so the job can be launched in Pinterest infrastructure, and the job can be upgraded gracefully. In year 2020, we have more use cases coming into the platform, covering key initiatives of company. So we built manually diagnosis tool called Dr. Squirrel. We enhanced the interval join operator since we see some issues with performance given our scale. We do the job management service so it can actively manage the Flink jobs running in our platform. We do release upgrades so that we can catch up with all the exciting and fast-changing releases in Flink and take advantage of all the new features or enhancement in much faster pace. We create validation tools so that users, when they upgrade or taking new releases in their jobs, they will have confidence their data is on par with what they have right now. So we kind of chain them together to build a Xenon CI/CD so that we can actually allow the user to more automate their self-serving service experiment on our platform. Last but not least, we heavily invest in Flink SQL. So we feel this is the future for our platform as we move in 2021. So let's go back to why Flink. So as I mentioned, we have several use cases evaluate during 2018 and 2019 timeframe. What we see from compared to all these different technologies, is Flink is really solid framework to run data flow model, and they struck the balance between maturity and novelty. On top of it, we see a great adoption across the industry, including Netflix, Uber, Alibaba, and other big use cases. So we gain the confidence this large-scale production use case can cater toward our needs and meet our web scale demands. We see the standard deployment, so we don't really need to kind of reinvent the wheel, try to run the job in our young cluster. Last but not least, we see a responsive user-focused email list, which Flink community has been built for years. With a detailed discussion, quick response, and often in-depth discussion to not only the utility part, but also the core part. All those points give us confidence this is the technology we can move forward with. Now let's dive into the use cases. What kind of use cases we have as we speak right now? So as we speak right now, our Xenon platform, which is Flink service on Yarn, have use cases covering from creator, shopping, ads, content distribution, experimentation, and even much more. So most of use cases from creator, shopping, and ads measurement, reporting, retargeting is building on top of data stream API. The content distribution is a cluster of use cases which are heavily machine learning focused. Experimentation is a real-time experimental A/B testing framework. There's a use case of anomaly detection, which monitoring the ML model serving quality, as well as online service quality. That will leverage partially on Flink SQL. So as I said, of our use cases, there's two important traits. One is its web scale, because we touch a lot of important sections, so we have naturally stringent SLO. Second, it's machine learning heavy. Because of Flink, Pinterest is heavily on the visual and video content, so naturally the machine learning, especially deep learning, is heavily used to run on top of Flink job. Now we have the use cases. Let's say we have exciting customers. They want to work with us. The next thing is where should we start as a team to support those use cases? So when we have a group of passionate people work together to start this journey of building Flink as a platform in Pinterest, we really started getting familiar with the kind of terrain of Flink streaming from both development and operational perspective. So we decided to build up something like a menu. Everyone can read it, they can follow instruction, and they can get things done regardless of whether there will be expert team members support them or not. So we started building some semi-menu process, which layouts more like user menu. So start from pre-development to the design reviews, to the onboarding, to productionization, to the operation. Of course, this is a relatively heavy process. So this cater towards initial kickstart, where we build this expertise. We're glad to see this process can be executed by new hires or a team member who haven't had done this before independently. So we keep iterating on those processes to make it more reflect what we have from on-call and from the feedback from customer. And then we start to automate some of the process to make the process lighter, less work for the customer and for us. So we do the source and schema validation, we do the change validation, we do the version upgrade automation, we do deployment automation, and sometimes right now even we do the operational automation, which goes back to a managed Flink application platform. Of course, that will generally give us some headroom to grow even more use cases. What's interesting along the way is we find the more testing and checks before we let them go to production, there usually leads to less operations. And when we have less operations, it generally leads us to have more time invest on automation and makes the process even simpler and more self-service. And then they direct the feedback to even less operations. When this cycle goes through a couple of times, we observe the platform stability really changing, kind of going up, even we have more use cases coming in. So the gist of it is automate when possible. Now let's use one of the process we built to showcase what this what this process will look like. So this is a production certification process. Essentially, that's a watchdog before users' dev job make its way to production. So we want to make sure those jobs are properly checked and verified and tested in the same manner. So we build this process to do those checks. There are basically 4 steps. First, we want the job running in dev environment for 12 hours without manual intervention. Second, we want to have a Jira tickets basically tracking what is the some metadata, some information about the job, especially how large resources are, what kind of thing they want trying to do, and what's the business impact for this job. And then we invite them to the staging with our automated testing environment, kind of simulates low spike, simulate large throughput, simulate the failure and recover. If they can pass, then we'll invite them to share a staging verification finding document with us with some template and examples for them to follow. We work with them to identify those open issues and resolve them. those open issues before the job can make its way to production. So the gist of this staging verification is to have a recoverable and performant job, which generally leads to at least 3x of headroom compared to production traffic. Of course, we'll help user set up the PagerDuty with template. But what we find out is through this process, especially for staging verification doc, we also train our customer to do some fire drill before their job goes into production. So now how can we ramp up the traffic, can simulate all those spike workload goes into the job? So our answer is unified source. I'll give a little bit more context in next slides. So unified source essentially is a API that can either talk to Kafka or to S3. Inside of Pinterest, we have something called Mercer. Essentially, that's a Kafka log persistent system. They pulled Kafka raw logs and zip them and put in the S3 directory with partition and offset information. So on top of it, we build a unified source in Flink 1.91. It can pull either from S3 of those zipped sources or from Kafka, depending on the timestamp, time range they were specifying. So it works pretty well for the bootstrap and backfill use cases. When users have issue with downstream, they can reprocess by defining the time range they want to reprocess without changing their code. So now with the unified source, we got a capability to run a bounded stream and unbounded stream from history to the future. Because Pinterest is heavily utilized Swift as a serialization format, so it gives us much simplicity, no need to translate the schemas from Avro to Swift or from Swift to Avro. Let's dive into a little bit detail how unified source or sync was implemented. So as you can see, when the unified source gets deployed of a given subtask, let's say subtask 1 and subtask 2, the unified source essentially is a composite of Kafka Flink consumer and Mercer file source. So let's say we start from historical timestamp. Then the unified source will be able to tell the Mercer file source, trying to scan the corresponding data partitions and find the corresponding files that has those information. Then it filters through the sequence files with the timestamp and starting injecting to the downstream jobs when they started seeing the predicates match. After the sequential pulling from Mercer source, then it will feed back to the unified source and tell them of a given partition this subtask is working on, what is the latest offset. And then Kafka consumer will honor this offset and continue starting from a Kafka partition with this offset. This gives us a capability to not stopping the job while consuming the job continuously. So this is one of diagram when we run this unified source. So when you read from Mercer, the throughput usually much larger compared to when they read from Kafka. This is because the Mercer is a Kafka persistent storage, and the information was zipped. So it has potential to be bounded by the network itself. So now we have a unified source, which means we don't need to change the user's code in order to consume from historical with a larger throughput compared to the Kafka. That sounds pretty good. But at the same time, when we actually run this, ask our customer to run this, and essentially recommend the unified source to all the customers, where all the customers are using right now, we saw two issues regarding to the bounded stream. First, as you can see from this diagram, the reading from Mercer is much more performant from reading from Kafka, which means if you have a two-stream join, if you have a slow pass, which essentially may be much more records per second, and you have a fast pass, maybe a much smaller Kafka topic, then the fast pass will progress much, much faster than the slow pass. What they essentially translate into Flink job is a fast pass will move ahead with timestamps, while slow pass is moving very slowly. And along the times, when it kind of progression, this will only get even worse until they really read from Kafka latest. To resolve this issue, we introduced rate limiting. So we basically trying to figure out what's the right throughput for the fast pass, kind of holding back a little bit to make sure their time characteristic, especially window scheme, can be aligned together. The second issue we observe is because the reading from Mercer is so performant, so the windows, those online jobs created fires much more frequently because of the event time scheme, the semantics. Without changing the job, we figure out a way to changing the watermark. Basically, we want to watermark as more kind of lazy watermarking instead of aggressive watermarking, so that the window triggering can be kind of throttled or rate limited in same fashion. So that's our kind of two improvements we put into composite the file source along with Flink KafkaSource. Of course, we also do unified sync so that user can either write to Kafka or write to S3 without code change. So in future, they can run the batch jobs and verify if the result produced from a bounded stream matches the result they expected from previous versions or releases. JobService. We just briefly talk about SDK work we built in Pinterest. Now let's dive into the deployment work. In Pinterest, we call it JobService. Let's start with Job Submission Service, aka JSS. What essentially JSS does is integrates with Pinterest Java model repository and build system, and to automate the Flink job building and launching experience. It also helps us to make sure we know exactly which commits our customer is deploying, so that it can be compliant with the various auditing or compliances. So the user experiences really start from go to the UI, pick a commit with the artifactory, which this jar is already available in S3. And then there will be a UI basically asks the customer whether they want to do a fresh deployment or they want to resume from a checkpoint or save point. If they say yes, a fresh deployment, then it do a RPC and hit the job service. Basically, job service will pull corresponding jars and orchestrate the gateway Flink CLI, and then submit to our Xenon clusters, corresponding Xenon clusters. When the job submission finish, it will write to MySQL database and keep pulling the resource manager regarding to what's the status for the job. So interestingly, this job service actually have a state machine. We'll see if we have time to talk a little bit more on detail. If the user say, no, I don't want to have a fresh deployment, what essentially they can pick a save point from the UI, and then we will honor that save point, kill the existing job by calling job service, and then deploy a recovery job through the job service to Xenon cluster. And then kind of job service will just take over from there to make sure only one job was running at one time. So over the on-call experience and working with customer, we find sometimes there are human errors. So people might click the submission twice or even 3 times while their downstream is shared Kafka queue or Hive partitions. So we build the deduplication logic to make sure even the double-click or triple-click the deployment, there won't be 3 jobs running at the same time. So what's nice thing about keeping this in the job information store is now you have a SQL database. You can query and get more information of which job is running and where it's running and what jar and configuration they are running. This is the first part of job submission service. Over time, it works pretty well until we saw some problem with AWS side. We observed AWS DNS outage, which almost our job failed at one time. Then we have to go through a painful manual process, trying to pull all these dead jobs configuration and manually launch by ourselves. Over the on-call, off-call review, we figure out we need to automate this process so that in future, if something catastrophe happen again, we'll be better prepared. So we build something called job management service. So essentially, the gist of our job management service is automation of actively manage and modify running jobs. The goal is to automate the repetitive operations on-call might need to take if there is outage, and quite quickly respond to the issues. So the GMS from this diagram, as you can see, is co-located with GSS. They actually talk to GSS to understand the job information. On top of it is also talk to different ZK cluster in different availability zones. So that if there are one availability zone having issues, we are able to find the information, tell GSS to kill that, and launch another job or recovery job in a different availability zone. We'll make sure there is no duplicates, no 2 jobs running in parallel. Over time, we find not all jobs are equal. Some of the jobs are definitely more important. So the GMS will honor the job tiering information instead of just do plan scan and sequential launch. Now we have the deployment, we have SDK, we have processes. What happens is we further automate all those together. we came up with the idea of CI/CD. So basic CI/CD is to mimic what deployment cycle look like when you user run a microservice or a online services. They build on top of a Sprinklr-based continuous deployment workflow, which our in-house infrastructure team is offering us. So the goal is really to automate the staging verification and data validation against Flink job changes. As you can see in this diagram, the changes in our term could be user make their code change to their Flink job. It could be we are releasing a new Flink version so that user can take this new version and test with upgrade. In CI/CD world, once user have a code landed, or once we push a new release, it will automatically trigger a jar building upload to S3. If user opt-in auto deploy, then we'll start a staging job against the newly built jars. And then after finish, they'll call the validation module. If the user confirm yes, then the job will presumably just recover from the latest save point and replace the current job running in production. So all those steps are coordinated with JobService, with Job Submission Service, JSS, and Job Management Service, JMS. So in validation pass, we really use the Lina Unified Source along with the Lina Unified Sync. We can use Lina Unified Source to bound the time gap of data we are looking at so that it's kind of fixture data. And we can use Unified Sync to output S3 so that we can run a query and compare with previous results before the change. This gives us much more headroom to work on even more interesting features and automation. So those are deployment side. How do we help our customer to support? Over time, we find the support workload was pretty high, especially when not many engineers really understand how to kind of familiar with Flink or data flow model to start with. So we kind of use this opportunity to build something that can address the majority of questions we get from the Slack channel. So we built something called Dr. Squirrel. So essentially what Dr. Squirrel does is a self-serving debugging and diagnose tools. It just simplifies the Flink job matrix access. It's automatically diagnose the data skew and back pressure as we speak right now. So essentially, the job diagnose service is tilling from Kafka, from matrix reports, and also from Yarn resource managers to generate and analyze the reports. This is the UI of Dr. Squirrel. As you can see, same jobs may have different job ID, depending on whether they change the logic, whether they do upgrade, or whether they launch multiple versions. And we put all this information together so that it's easier for user to kind of look and compare back and forth. If you click into one of the link of Dr. Squirrel Run, you will see I have a linkage to all the Flink matrix, as well as some of diagnosed information we are giving to the users. So we're really kind of looking at what is utilization, whether the resources are heavily utilized, underutilized, or over-provisioned. As well, we find sometimes people, when the user were asking whether their job were not running properly, we started giving user, oh, maybe there's back pressure issues. Maybe there are data security issues. Your partition key have a really hot key. So Dr. Squirrel can answer those questions for us instead of on-call clicking through the links and trying to answer users repetitively. Flink SQL. So we are heavily invest on Flink SQL in H2 because we really believe SQL is one of the future in data processing as a whole. So as we speak right now, Flink SQL on Xenons has many in-house built components, mainly because the Flink SQL right now doesn't support Thrift. So we build table schema inference from Thrift schema. Our schema is very complicated with nested structures and complicated data types. So we actually trying to reinforce our idea of using Thrift end-to-end. So user, instead of orchestrating their schema manually, line by line, we can inference them for them with a Thrift schema. Then we build the UDF back into a Java monorepo. Recall the GSS will actually talk to Java monorepo and build the jars. So this part can be shared with our current deployment system. We also ask Flink, use Flink SQL talk with unified source, so it can leverage and access the Mercer files in S3 as well as Kafka without without a lot of schema translation. And because we use Thrift end-to-end, the experience is much simpler. Right now, we are adding more integration with Hive. Again, because we use Thrift end-to-end, so the Hive integration as sequence file can be much simpler compared to other data lake options. And last but not least, Flink SQL in Xenon is also runs as a Flink job and goes through all the deployment and automation CI/CD system we built. Now let's use some time to showcase of what we do. This is fast creator use case, one of the important use cases in our platform. So what it basically does is when a creator or a user create a new pin, we want to give user real time how their pin perform, how many people are seeing that, and how this kind of trending will look like in real time. What's interesting is, first of all, we want to do the stats for last 7 days instead of last 24 hours and perform real-time analytics. The second is this project has been failed previously because of technology constraints, streaming technology constraints. Building on top of Flink on Xenons, we use a unified source to bootstrap state from 7 days ago, instead of waiting for 7 days for Kafka to build up state. We can do this within 3 or 4 hours. And we were able to verify in staging the job can demonstrate at least 3x of throughput when we have a Kafka backlog simulated and drained. We observe data security issues in production certification process, where it inspire us to feedback this to the Dr. Squirrel. We use JobService management, GSS and GMS to upgrade the job from V1 to V5 seamlessly. Last but not least, these jobs have been very stable since April, launched this year. So this is became a winning story in the company. And that's pretty much what I want to talk about today. I'll leave some time for Q&A and answer any questions folks may have.